All right, so now let's look at this PhET simulation. And so this is just kind of like an atom builder. And all I want to use this for is to show you again how these, it's kind of a refresher, right? We learned about the three subatomic particles, but this is again what I want to emphasize here. So let's really quick, let's just make, let's see, not helium, let's make carbon. All right, so one more. So again, remember we have 6 protons. So right here, carbon, you can see right here the 6, right? That's the atomic number. It means there are 6 protons. And you see here, it's showing you that we have, and let me bring up the neutrons, right? But look what happens right here, the atomic mass. We have 6. Remember, atomic mass is protons plus neutrons. So let's get, actually up here we have the atomic mass. Let's get 12, right? 6 protons, 6 neutrons. All right, so again, this is what a carbon atom is, right? It has 6 protons, 6 neutrons. So what we want to do now is then again, this is why I want to point this out, that here we have in the first shell, we'll bring up 2 electrons, right? So remember the first shell, and look what happens when I try to put a third electron on this first shell. It doesn't work because remember, you can only hold a maximum of 2 electrons on the first shell. But look what's happening to the charge, right? Now we have more positive protons. That's why you have a +3 right here, because there are more protons than electrons. But look at this right here. So keep adding. There are 2, 3, 4, and now it's neutral because you have look 1, 2. You have 6 of these blue electrons, and you have 6 of the protons, so they cancel each other out, right? But let's go ahead and put 2 more. Right, so here you see now we have 1, 2, 3, 4, 5, 6, 7, 8. And I'm just doing this to show you that you cannot have more than 8. So it only lets us go up to this shell right here. But if I were to try to bring another electron here, it would actually kick it back out because you cannot have more than 8 electrons. And again, this is what most atoms are trying to strive towards, is getting this 8 electrons on their outer shell. So 2, maximum of 2 on their first shell, a maximum of 8 on every shell after that. Right. And in this case, let's go ahead and go back. So here you have a -4, and that's again because we have 4 more electrons than we do protons. So let me get rid of 4 of them just to make it a neutral atom. Right. So now you see the charges right here. It's not negative or positive. It's just a 0. So it's a neutral atom. Right. But again, 2 in the first shell and a maximum of 2 on the first shell, a maximum of 8 on every shell after that. Right. Doesn't necessarily have to have that many, but that's the maximum that it can hold. Right. And so right here, these questions, we'll have questions on the formative. And so for right here, why are electrons important? So this is one of the things that, one of the main topics that we're talking about are electrons, but especially valence electrons. So valence electrons, I mentioned earlier, they're the outermost electrons of an atom, right? So the electrons on the outer shell are the valence electrons, and then the outer shell itself is called a valence shell. These electrons are really important because they're the ones that are going to determine an atom's electronegativity. And remember this, electronegativity just means how badly an atom wants electrons, right? So if something is very electronegative, it's like an electron hog. It's trying to hog all the electrons around it, right? And some atoms are more electronegative than others, right? So they tend to basically steal them away from other atoms. And ionization is also determined by electrons on the outer shell. In ionization, just remember that a positive or a negative atom is called an ion, right? So a positive ion is called a cation. A negative ion is called an anion, right? And these are just, again, positive and negative. And we're going to see right now why that's important, right? And this also leads to things such as covalent and ionic bonds.